Hello students, this is Nilanjana Sanyal from My Math Friend Online and e-Porashna. Today we will be learning about the section formula. So let's start. This is a grid paper and these two are the two coordinates, namely the x-axis and the y-axis. Now we are having a line segment PQ with the endpoints as P and Q respectively. And what are the coordinates of the endpoints P and Q? P is having the coordinates as x1, y1. And Q is having the coordinates as x2, y2. Now, T is a point on the line segment PQ having the coordinates x, y, which divides this line segment PQ into two segments having lengths of m1 and m2 units respectively. So PT by TQ will be equal to m1 by m2. The point T is on the line PQ, so it is dividing this line segment PQ internally. This section formula is valid for points which divide a given line segment internally. Okay, we will be doing the section formula of points which divide a line segment externally in some other session. Okay, but for this session we will be taking up only internal division of line segments. Now we will be finding the coordinates of this point T which divides this line segment in the ratio of m1 is to m2. We will be finding the values of x and y in terms of the coordinates of this point P, this point Q and the m1 and m2. For that, we construct perpendiculars. We drop a perpendicular from this point P on this line and name the foot of the perpendicular as C. We drop another perpendicular from this point T on this line and we name the foot of the perpendicular as point D. Okay. Now coming to these two triangles. Okay, this one, the smaller one, and this one, the big one. Triangle PCT, this one, is similar to triangle TTQ, this bigger one, by the EE criterion or the angle criterion. How? Obviously, you must be knowing how to prove these two triangles to be similar, but even then I am telling you. These two are two parallel lines PC and TD and PQ is a transversal. So the angle TPC, that is this angle TPC, this angle is equal to angle QTD, that is this one, QTD, because these two are corresponding angles. These two are parallel lines PC and TD, therefore these two angles QTD and angle TPC are corresponding angles, hence equal. Again, taking these two parallel lines, this TX and QX2, even these two are parallel lines and again PQ is the transversal. So angle PTC, that is this angle, PTC, this one, is equal to angle TQD, that is this one. Again, these two are corresponding angles, hence equal. Angle PTC, that is this angle, is equal to angle TQD, that is this angle. These two are equal because these two are corresponding angles. And TX and QX2, these two are parallel lines. Hence, the corresponding angles will be equal. So, by angle criterion, we can see these two triangles to be similar. They are similar. Now, one thing that I would like to mention is that students, please name the similar triangles properly by point-to-point matching. It is absolutely essential to name the two similar triangles properly. Only then can you get the corresponding sides. Otherwise, I have seen many students getting confused when they are asked to find the corresponding sides, because you know that the corresponding sides will be in proportion for similar triangles. But for that, you have to know which two sides are corresponding sides. So as soon as you write or name the two triangles properly, you will be seeing that the corresponding sides become so very evident. How do you name the two triangles properly? By point-to-point matching. You see, I am saying angle TPC, that is this one. The middle letter denotes the angle. So middle letter TPC, so this is the angle, is equal to QTD. So this is the angle. So if I start with the letter P for this small triangle, I should start with this letter T for the big triangle. This is the point-to-point matching, because these two angles are equal. So since I am starting with this letter P for this small triangle, I should start with the letter T for this big triangle. Okay. Now coming to the second angle. We are saying that angle PTC, that is this one, is equal to angle TQT, that is this one. PTC, angle PTC is this, and angle TQD is this one. These two are also corresponding angles, hence equal. Now PTC, the middle letter is T, and for TQD, the middle letter is Q. Since I have written T as the third letter of this triangle, Q should be the third letter of the bigger triangle, and the remaining letter will be coming in the middle position, obviously. This is known as point-to-point matching. At least you have to get two angles to be equal, only then can you prove the two triangles to be similar. Or you have to have one of the three angles to be similar and the sides including those angles to be proportional. If you have proportional sides, then it's very easy. You know which two sides are corresponding sides. But when you do not have any knowledge about corresponding sides, you have knowledge about angles, which two angles are equal, how to find the corresponding sides. For that, you have to name the triangles properly, first of all, by point-to-point matching. Now you see, I have obviously for each ratio, you have to take the numerator from the first triangle and the denominator from the second triangle. So I am taking PT, that is the first and the third letter. P and T, first and the third letter of this triangle PCT. So the denominator will be containing the first and the third letter of the second triangle TDQ. So it is PT by TQ. These two are corresponding sides. You see, PT by TQ. Obviously, both these sides are the hypotenuse of the two triangles, right angle triangles. Okay, obviously these two are corresponding sides. Next is PC, the first and the second letter of this triangle. So the denominator will be the first and the second letter of this triangle, that is TT. Now the second and the third letter, CT. So for the denominator, it is DQ, second and the third letter. Now what is PT? T is this point on the line segment PQ, such that it is dividing this line segment into two parts, PT and TQ, having lengths equal to M1 and M2 units respectively. So PT is equal to M1 and TQ is equal to M2. So in place of PT and TQ, I have written M1 and M2. Coming to PC, these two are the points, P and C. Now these 2 points are lying on the same horizontal straight line. So they are having the same ordinate value. y is equal to y1 for both these 2 points. But the abscissa value is different. P is having an abscissa value of x1 and for C it is x. I have taken the second point minus the first point, so I have written x minus x1. Whatever you do, if you want to take first point minus the second point, no harm, but you have to follow the same rule every time. So if you take x1 minus x, you have to take x minus x2 in the denominator. Every time I have taken the second point first minus the first point. So it is x minus x1. I have written x minus x1. For TD, this is the line TD. Again, they are on the same horizontal straight line. Therefore, their ordinate values are the same, namely y. What is differing is the abscissa value. So it is d minus t, and for d the abscissa value is x2. So it is x2 minus x. This is the denominator. Coming to the third ratio, CT, this one. Now they are lying on the same vertical line. So the abscissa value will be the same, but the ordinate values will be different. Again, I am taking the second minus the first, so it is y minus y1, because y is the ordinate value of this point T and y1 is the ordinate value of this point C. So y minus y1, y minus y1, and dq, this one. Again, on the same vertical straight line, so having the same abscissa value but different ordinate values. So q minus dq is having an ordinate value of y2 and d is having an ordinate value of y. So it is y2 minus y. Okay. So this is a relation which I have numbered as A or marked as A. This is relation number A. Now from this relation we will be framing two equations. So m1 by m2 equal to x minus x1 divided by x2 minus x. This becomes our equation number 1. And equation number 2 is m1 by m2 equal to y minus y1 by y2 minus y. This is our equation number 2. Now first of all, since we have taken this equation 2 afterwards, means this is our current equation. So let us solve this equation first. What do? We just cross multiply. This is a simple thing. How do we solve an equation, a linear equation? Just on cross multiplication, we will be getting a linear sort of an equation. So m1 multiplied by y2 minus y1 equal to m2 multiplied by y minus y1. This is equal to m2y plus m1y equal to m1y2 plus m2y1. Now let me show you how am I getting this. I know that most of you will be able to deduce this, but still if you have some confusion, I am showing you because I did not have sufficient space, so I have skipped 1 or 2 steps. Okay. So after this we can write this as on opening the brackets. Let us start from this position. This is equal to m1y2 minus m1y is equal to m2y minus m2y1. Okay. So we will be taking the y terms to one side of the equal to sign, and we will be having all the other terms on the other side of the equal to sign. So since we are having this minus sign over here for m1y and this is m2y is a plus sign, so we are taking this to the right hand side. So this becomes equal to, and we are bringing this term having the negative sign to the left hand side. So it becomes m1y2 plus, this is m2y1, didn't have enough space. So now this is m1y plus m2y. It is m1y2 plus m2y1 equal to m1y plus m2y. Now you can just take this to the left hand side and write this first and write this afterwards. It doesn't matter. These two will be together, these two will be together. So I have written this in the right hand side of the equal to sign. Over here I have written these on the left hand side of the equal to sign. It doesn't matter which side you are writing, when you are writing the terms together. These two are to be together on the same side of the equal to sign. So I have kept these two terms to the left hand side of the equal to sign, and these two terms are on the right hand side of the equal to sign. Okay. Now we will be taking out this y as the common factor from these two terms, and we will be having m1 plus m2 within the bracket, which when taken to the right hand side will be coming down as the denominator. So we are having the value of y, that is the ordinate value of this point t, which is equal to m1y2 plus m2y1 divided by m1 plus m2. It is very easy to remember. You see, first of all we say 1, 2. This is the order that we usually use, 1 then 2. So it is m1 plus m2. And everything is having plus sign. So you do not have to remember where is it a plus and where is it a minus. Everywhere it is the plus sign. So m1 plus m2 in the denominator, we are always starting with this 1. For the numerator also we will be starting with m1. Because we have started with m1 in the denominator, we will be starting with m1 in the numerator as well. And 1 should be paired with 2. We will not be having two 1s. 1 should be paired with 2. This is the only thing that you have to remember. Since we have taken m1, so the next factor will be y2. It cannot be m2 because in a single term we will be having a single m. So m1, with that only y2 can be taken because we have already taken this one. So m1 y2, m1 plus m2 is in the denominator, so we will be starting with m1 in the numerator as well. And as soon as we write m1, the next factor will invariably be y2 because we cannot have m2. We will not be having or not be taking m2 in the same term. And y, it will be y because we are finding the value of y. So y, and what will be the subscript? 2, because we have taken 1. So it is m1 y2 plus, next since we have taken m1, it will be now m2, and m2, 2 should be paired with 1 because 2 will not be paired with 2. 2 and 1, they just gel together very well. So m2 y1. Okay. So m2, as soon as we write m2, the next term that we will be tempted to write is obviously y1. This is the ordinate value of this point t, which divides this line segment into two parts internally. Means it is on the line segment, given line segment. We will be knowing about the section formula for a point which divides a given line segment externally in some other session. But for this session, we will be confining ourselves to internal division. Okay. Now we will be coming to the equation number 1. We will be solving for x from equation number 1. So we are writing this equation number 1, and again we will be cross multiplying. So it is m1 times x2 minus x equal to m2 times x minus x1. And the same thing over here that I have done, you have to do the same thing, and you will be getting m2x plus m1x equal to m1x2 plus m2x2. Okay. So we take x as the common factor outside, and we will be having within the brackets m1 plus m2, which will be coming down. So we have x equal to, again you see these two, m1 y2. In place of y2 we are having x2 and m2 y1. In place of y1 we are having x1. So you do not have to remember much. Only thing that you have to remember is m1 plus m2. m1 will be coming first because 1 is first. We say 1 and 1 comes before 2. So it is m1 plus m2. Just this thing you have to remember. And since you are writing the denominator as m1 plus m2, you have to follow the same trend in the numerator as well. So m1 will be coming before as soon as you write m1. If it is y, you have to write y. If it is x, you have to write x. And what about the subscript? Since it is m1, the remaining number is 2. So we write 2 plus m2. Since it is x, we are writing x. Then remaining number is 1. We have got the formula. Okay. So don't have to remember anything. Only thing is m1 plus m2, and this just follows. 1 comes before 2. So you don't have to remember it all actually. Okay. So the coordinates of the point T, that is this point, the coordinates are x comma y, and we are having the values of x and y, which divides the line segment PQ internally in the ratio of m1 is to m2. Or in place of x we are writing m1 x2 plus m2 x1 by m1 plus m2. This is the thing. Comma, in place of y we are writing m1 y2 plus m2 y1 divided by m1 plus m2. This is known as the section formula. So students, this brings us to the end of this session. Thank you for hearing.